Okay, so one thing you need to be very familiar with are the graphs of y equals sine x and y equals cosine x, and their various different transformations. And I'll go more into those in a different video, but right now I want to look just at the basic function y equals sine x. So y equals sine x, one thing you need to know about it is that it has a period of 2 pi. What that means is it repeats itself every 2 pi. And the 2 pi is in a unit called radians, and I'll explain those in another video as well. But just think of it as the x-axis right now, and every 2 pi it completely repeats itself. And sine x also has y values between -1 and 1. It's always between -1 and 1 if you have y equals sine x. And then here's how it looks. So you have sine x starts at the origin at 0, 0, and it has period 2 pi. So it's going to go to 2 pi, and it'll have the same thing over on the other side to -2 pi. And then it would repeat itself from 2 pi to 4 pi, and then to 6 pi, and so on. And whenever you're graphing one of these trigonometric functions, your best bet is to take the period and break it up into 4 parts. So we're going to divide this 2 pi into 4 parts. So the middle would just be pi, and then the middle between 0 and pi would be half of pi, or pi over 2. And between 1 pi and 2 pi would be 1½ pi, or 3/2 pi, which we write as 3 pi over 2. And so sine goes between 1 and -1. It starts at 0, 0, and each of these little points that I put in here is where it either reaches a maximum or comes back to the axis. So it starts at 0, 0 and goes up. It goes up to 1, and then it crosses the axis at pi, and then is at its minimum at 3 pi over 2, and then at its maximum, it crosses the axis again at 2 pi. And then if I were to break this next one up into 4 parts, we'll repeat the process. At the first one, it'll go up to its highest point, and then cross the axis, and then its lowest point, and then cross the axis. So it looks like this. Oh, I can't draw. You can see the tremors in my hands when I do that. And it goes on. Whoa, what happened there? Don't do that. Okay, now going the other direction, we're going to have the same thing. And again, divide it up into 4 parts. So I'd have the halfway part would be -pi. Halfway between -pi and 0 is half of pi, or -pi over 2. Halfway between -1 pi and -2 pi is -3 pi over 2. And it's starting here, it's going down in this direction, down, and then crosses the axis, and then it's at its maximum point, and then there. So there, 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 and there. And that is the graph of y equals sine x. And then if you multiply the x by something, or on the outside, you're going to change things, and I'll explain that in another video. And just really quickly, I'll show you what to do with cosine. Cosine is the same idea, except you start at 1. So you start at 1 going down. And so this would be your highest point, and then you cross the axis, and then the lowest point, and then you cross the axis, and then the highest point, cross the axis, lowest point. And you just repeat the pattern. And if you break your period up into 4 parts, that's going to be your clue. Yeah, I can't draw under normal circumstances, and my hand is in a big cast right now, so that's particularly bad. But there it is. So that's sine and cosine, and that's going to be the end of this recording. Alright, so let's look at some functions and try to determine if they are one-to-one. So let's say I have y is e to the x plus 2. Well, e to the x is one-to-one, so if I shift it up by 2, it's still one-to-one. That's terrible. E to the x, that's not even e to the x, that's e to the minus x. E to the x is that, shifted up by 2. Okay, what about y equals negative natural log of x? Well, we know natural log of x looks like this. So negative natural log of x is shifted or reflected about the x-axis, so it looks like this. And so that is still also one-to-one. So one-to-one, one-to-one. What if I had y equals cosine x plus 2? Well, I know cosine x looks like this, which is not one-to-one, because a horizontal line can cut it in more than one place. If I shift it up by 2, it'll still not be one-to-one. So this is no. What if I had y equal negative cosine x? Well, that's going to be cosine x, but just shifted across or reflected across the x-axis. Still not one-to-one. So those are not one-to-one. All right. Pause it for a second. Okay, now let's say I have a function f of x equals negative x to the 4th plus 3x squared plus x, and I want to find f inverse of 1, and I want to find f of f inverse, well, this is a bad function because that's not one-to-one. Let me get a one-to-one function. X to the 5th plus 3x to the 3rd plus 1, and I want to find f inverse of 5. And I want to find f of f inverse of 7. So f inverse of 5, I want to find the x that makes this true. Well, that would be very difficult to solve. But if I just plug in 1 here, 1 plus 3 plus 1, I get 5. I see that 1 is the solution to this. So I can say f inverse of 5 equals 1. Now for f of f inverse of 7, the whole point of inverse functions is that they are inverses of each other. They undo each other. So I don't have to know what f inverse of 7 is. Whatever it is, if I take f of it, I get 7. Okay, now let's say I have y equals x squared minus 10x. X is greater than 5, and I'm supposed to find the inverse function. Alright, so I start by swapping my x and y. X equals y squared minus 10y. Now the way to solve this one is by completing the square. Like, I haven't done that in forever, but let me remind you how to do it. You take this number, negative 10, divide it by 2, and you get negative 5. Hold on to that number, we'll need it. Square it, and you get 25. So I add 25 to both sides. So I get x plus 25 equals y squared minus 10y plus 25. Now I told you we'd need that negative 5 in a minute, and here's why. Because this factors into y minus 5 squared. That's where that negative 5 is used. Now I take the square root of both sides, and I get y minus 5 equals the square root of x plus 25, and then I add 5 to both sides. Y equals the square root of x plus 25 plus 5. Then I want to check, did I make the right choice here by using the positive square root? So my domain is x is greater than 5. That has to be my range of my function here, and it is, because the smallest this square root can be is 0, and so 5 is everything bigger than 5 is the range. So this is the inverse of that function. Okay, so if you're just looking at how to do it, that's how you do it. If you want to see another example, I'll do another example right here. So let's say I had y equals x squared minus 14x with x greater than 7. I complete the square, so I take half of negative 14 is negative 7, and I square it. I get 49. Add that to both sides. Y plus 49 equals x squared minus 14x plus 49. Then this side is y plus 49. This side factors into x minus 7 squared. Take the square root of both sides, and I get the square root of y plus 49. Oh, I forgot to swap my x's and y's. We'll do that at the end. Equals x minus 7. Then I add 7 to both sides. Square root of y plus 49 plus 7 equals x. So I waited to the end to swap my x and y. Y equals the square root of x plus 49 plus 7, and that would be my inverse function. Now, to prove that it's my inverse function, if you're not interested in this, you don't have to watch it. But if it is an inverse function, then f of f inverse should equal x. F of f inverse should equal x, because if I apply f inverse and then f, they should undo each other, and I should just get right back to x. So f of f inverse would be f of the square root of x plus 49 plus 7. So this is f of f inverse. Now f was x squared minus 14x. F was x squared minus 14x. So f of the square root of x plus 49 plus 7 is square root of x plus 49 plus 7, all squared. So I'm plugging this in for x. I'll plug it in both places. Minus 14 times the square root of x plus 49 plus 7. So I replaced x with the square root of x plus 49 plus 7. Now if I FOIL this out, I will get square root of x plus 49 times square root of x plus 49 is x plus 49. And then I'll have plus 7 times the square root of x plus 49, and I'll have that twice. So it'll be plus 14 times the square root of x plus 49, and then plus 7 is plus 49. And then minus the square root of 14 square root x plus 49 minus 14 times 7, that's 28 carried to minus 98. Okay, now if I combine like terms, 49 plus 49 is 98 minus 98 is 0, plus 14 times the square root of x plus 49 minus 14 times the square root of x plus 49 is 0, and I'm left with x. So I was right, that was in fact the inverse function. I hope you enjoyed that.